So in this lecture of building construction and engineering geology, we are going to talk about this specific topic, brick or bricks. So as you can see in the diagram, we are looking at a single unit, that is a brick. So when we say brick, we are talking about a basic building block of a structure. In the same way, for a human body, when we say a human body's basic building block, it is cell. Similarly, we can use the same verbal similitude to talk about structure, and in the structure we can say that the single building block, okay, the single building block of a structure can be a brick. Okay, we are saying can be a brick because not just brick, we have to use cement, concrete, water, steel and many other ingredients. But when we say building, the basic thing we remember or we recall the color, the shape, the texture, that is of a brick. Okay, so that was for introduction. Now let's see some philosophical take on this basic building unit, that is a brick. The famous architect Louis Kahn says that even a brick wants to be something. Yes, that's right, because when we are saying that one single brick is there, you can use it as a weapon, you can use it as a building block, you can use it as a weight or paperweight, whatever. But if you arrange the brick in a specific manner, then it can form a masonry, right? Okay, number of such masonries, number of such wall can make up a structure. The structure can be a home, or let's say a monumental structure, or let's say a place of worship, or let's say a high-rise building. Therefore, a brick becomes the basic single unit of a structure, and when you place the bricks, when you make up the masonries, when you make up the walls, it leads to some structure. Okay, it makes up a structure. All right, so this is some sort of philosophical take by the famous architect Louis Kahn. You can find the reference of this specific statement in a movie, Indecent Proposal, released in 1993, and the protagonist of the movie, Woody Harrelson, repeat the same thing. Okay, then details and nomenclature of a brick. See, whenever we say some object is there, some technicalities will always be associated with that thing or that object. Therefore, our brick, that is our basic building unit, also has some technicalities, or let's say nomenclature, or let's say technical terms associated with it. Okay, the first interesting thing that you come to see here is frog. Okay, now what frog is? Let's say this rectangular block is a brick. Then we need some indentation over it. We need some grooves in the brick so that the mortar that is going to be filled up, or the mortar that is going to be placed over this brick, should form some sort of locking mechanism, or should form some key. Interlocking mechanism should be formed whenever we are placing some sort of mortar on the brick. That's why frog acts as the key over here. Okay, it acts as key, means whenever you are placing mortar on this space, and on this space another brick will be there. That's why this specific groove, this channel, will be acting as a key or interlocking mechanism for the two bricks. Then the longer face is called as the stretcher face. Then the short face in cross section, okay, it is the header face. Then the bottommost portion is called as bed. Obviously on this surface we place the brick. Then arises are the side edges. Okay, the edges of brick are called as arises. Okay, and the distance along the stretcher face in between the edge of frog and the outermost edge is called as margin of the brick. Okay, these are the technicalities or terms associated with this thing, brick. Now let's see what we exactly desire or what we demand from a brick. Okay, since we saw a brick is a basic building unit or basic building component, then there must be some role or there must be some responsibilities or there must be some expectation that we have from this building component. Means how a brick should be, okay, how it should behave, how it should act when it is placed in the structure or when it is being placed in the structure or even before placing it in the structure. See, regarding water absorption, 20% or less is the limit for absorption of this compound in a brick. And how we are going to carry out this specific test, or let's say all these tests are the site test or the test for characteristics, or let's say test for qualitative analysis of a brick. Now whenever we are carrying out this test, and this test can be carried out on field also, for that, for having all these tests done, we need to bring out total 5 brick from the given stack. Okay, we will be taking out total 5 bricks out of the given stack, and these 5 bricks should be taken out from the stack randomly. Means let's say out of 1000 bricks, if they are placed in a specific position, then from 5 position you should take the brick, and then we will carry out all these tests on this 5 number of bricks. Okay, and selection should be random. Now the water absorption test by dry wet, what we will be doing, we will be placing the brick in water. The brick first of all should be dry, then after 24 hours we will be measuring or we will be testing how much weight that brick has gained, and the weight gain of the brick will be because of this thing, H2O. And let's say 100 gram is the weight of the brick. Okay, so we are theoretically talking this, and this is for example, let's say 100 gram is the weight of the brick. Then in case after 24 hours after the submergence of the brick in water, pure water, if the weight is let's say 125 gram, then the absorption is too high, we cannot accept this brick. In case after 24 hours the 100 gram brick became 115 gram, means the percentage weight gain is below 20%. That's why we can say that this specific brick is acceptable. Alright, then minimum crushing strength, it should be 3.5 Newton per mm square. Okay, if the value goes below 3.5, then the brick should not be at all accepted. Then indentation test, for this you have to use simple tools such as let's say nail, or you can use a key also. Okay, if you scratch the surface of the brick by using this nail, iron nail or key, then there should not be any visible scratches on the brick. Okay, on the surface of the brick there should not be any visible scratches or let's say indentation marks. Then the next test, homogeneity, smoothness and freedom from void. See, homogeneity or smoothness or void free structure in a brick is obtained when the material, the ingredient that are being used for making up that brick are of high quality. Okay, when we say the word homogeneity, it means that whenever you cut open or let's say break open a brick, then the texture, the color, the appearance, the characteristics of the brick on the broken portion and on the outer portion should look almost similar. Okay, and void free means there should not be any space present inside or holes present inside the brick. Then another test, which is a very simple one, you must have done this during your diploma or on any site visit. If you take 2 bricks together in your 2 hands, if you take 2 bricks together and if you just strike them together, then you will be hearing some sort of ringing sound. Okay, some sort of ringing or let's say clinging sound instead of the basic third sound. Okay, if you hear this third sound, it means that the bricks are either of low quality or they have absorbed a large amount of moisture in them. If you can hear a crystal clear ringing or clinging metallic sound, then it means that the brick is of high quality. Then efflorescence, in case the ingredient of the brick that are being used or that were being used for making up the brick, then the ingredient would be having some sort of alkalis in them, then this specific thing, efflorescence, takes place. Okay, efflorescence means if you submerge a brick underwater, or let's say if you sprinkle some amount of water on a brick, then after some time white spots can be seen on the surface. In case the alkali content of the ingredient of the brick is too high, then there will be high or large efflorescence. See, efflorescence in a brick is something that cannot be totally avoided, but there is a limit, there is some sort of range in which efflorescence is acceptable, and beyond that limit efflorescence is not acceptable. Efflorescence indicates nothing but the amount of alkalis present in the brick ingredient. Then regarding dimension, yes, the edges should be sharp, all the edges of the brick should be parallel to each other, and the edges, or let's say the sides, should be very, very straight. Okay, so these are the desirable or demanded properties of a brick. Then let's see what are the specific ingredients that we are going to use for making up a brick. See, here a chart has been provided and brick constituents have been split into the respective percentage ranges, and the ranges have been provided in percentage with minimum and maximum. Now here the green thing indicates that when, let's say, first example is alumina. When alumina is present in the brick, or let's say alumina is present as brick constituent in between 20 to 30%, precisely between 20, more than 20 and less than 30, then it imparts a useful property of what? Plasticity. Okay, and in case the percentage goes below 20 or goes more than 30, then this red coloration phenomenon takes place, which is shrinking and warping. Shrinking and warping are related to the volume, or let's say shape of the brick. Okay, shrinking means whatever the specific dimensions of the brick that are desired, then after making up the brick, because of high alumina percent, the brick may shrink, means it is getting diminished in its dimension, and warping means getting shape out. For example, let's say a straight brick is desired after its burning in clamp, or let's say kiln. Then in case alumina percentage is getting too high, then warping may take place. Okay, warping causes the brick to become out of shape, or let's say shape out of the brick takes place. Then silica, another major constituent, that is the most abundant constituent of a brick, is silica. Silica is present in brick as 50% minimum to 60% maximum. When silica is present in optimum amount, then it imparts the fusing and plasticity phenomenon in the brick. Fusing means all the constituents of the bricks are fused together, are merged together, are molten together to form a homogeneous mass. And plasticity means the property by which whatever amount of stress you will be applying on the brick, but the brick won't be changing its dimension, or let's say shape. That specific good property will be assigned to the brick by this thing, silica. Then if the silica percentage goes too high, then the brittleness thing will be taking place. And when we say brittle, something is brittle, then with application of some stress, the brick may not take or may not sustain the load, or let's say stress, and may directly break into part. Okay, break into smaller part. Then lime should be present in 1%. The optimization of lime content prevents shrinkage in the brick, and if we are diminishing or if we are expanding the content of lime, then it causes melting of the brick. Okay, means content inside the brick may melt, and the shape out, complete shape out, or the melting thing can totally render the brick useless. Then iron oxide. See, this specific constituent of brick impart the specific yellowish orange brown color of the brick. The characteristic color of the brick is imparted to it by this iron oxide. Okay, the maroon or reddish yellow color of the brick is imparted to it by iron oxide, Fe2O3. Then in case this iron oxide constituent percentage goes beyond the range or goes beyond the specified limit, then you can see blue or black spot or blue or black coloration or some dark spot on the brick. Okay, means iron oxide's percentage, if it is kept in optimum range, then from the color itself you can determine, you can say that the quality of the brick is good or bad, or let's say very, very ugly. Alright, then the final constituent of brick is magnesia. Magnesia reduces this specific thing. It restricts the amount of shrinkage that takes place in a brick when the brick is burnt in kiln or clamp, or when you increase its percentage, then it may lead to decay of the brick. Decay of the brick means the constituent may fall apart, or the brick may fall, or the brick may break into small constituents. Okay, so these are the brick constituents that we require, or the ingredients, or that makes up the basic thing as the recipe of the brick. Alright, then let's talk about what should not be there in the brick. Now we saw specifically here that what should be in the brick and how much the constituent should be present in the brick. Now let's see what should not be there in the brick. Means what should be the restriction to some sort of foreign material. See, in case iron pyrites are present in the brick, then it may lead to crystallization. Means small crystal, small shiny crystal may be seen in a brick in case iron pyrites are present, and this crystallization leads to brittleness, and brittleness leads to weakness in the brick structure, and weakness means low quality brick. Okay, then organic matter. See, in case while you are unsoiling the earth for making up bricks, and in case organic matter is present, then organic matter ultimately decays. Okay, and whenever in a brick structure, if organic matter spots are present, then after some time, even during burning, the organic matter may burn away, and it may render some void presence, or let's say space or hole presence inside the brick. And more the number of holes, more number of voids that are present in a brick, it leads to diminishing in the quality of the brick, or let's say the brick becomes weak. Then pebbles and stone. Whenever pebbles or stones are present in the brick, they do not act as let's say reinforcement to it. They do not add to strength, but they take away the strength of the brick. For example, in case in a brick on the corner spot, if a pebble is present, now if because of some force, since it is not part of homogeneous ingredient of the brick, now because of some force, because of some happening, if this pebble gets away, okay, if this pebble gets thrown away from the brick composition, then it form a void over here in the brick, and more the number of pebble, more the number of stone will be compromising with the homogeneity of the brick. That's why uneven breaking or brittleness, or let's say less strong bricks may be rendered whenever pebbles and stones are present in the brick. Then obviously alkalis. We saw this specific thing while we were discussing what are the desirable characteristics or desirable properties of a brick. Whenever alkalis, or simply let's say salts, whenever salts are present in the ingredients of the bricks, and when you try to moisten the brick, or let's say when you are trying to burn the brick, then all these alkalis react with the present moisture in the brick, and they try to escape the brick structure. Since salts are some sort of precipitate, when you are trying to burn the brick, and in case alkalis are present, and these alkalis will be coming up to the surface of the brick while the brick is getting burnt, or when it is coming in contact with the moisture, then whatever residue or precipitate of the alkalis will be on the surface, outermost surface of the brick, and the moisture will be getting away. Now this specific white spot, or let's say precipitation of salt, causes the brick to lose its property. Okay, the properties such as its texture, its color, and its overall strength. That's why these are the parameter, or let's say these are the ingredients, or these are the foreign object that should not be present in a brick mix. Alright, now the next thing we want to highlight or focus is manufacturing process. See, if you want to divide the total process into 4 small stages, then the first stage will be clay preparation, that is to prepare the dough. Okay, then second will be molding the dough, okay, molding the mass, then drying the bricks, and then ultimately burning. Now the first stage, that is clay preparation, consists of unsoiling. Unsoiling means whenever you are going to find soil or whenever you are going to find clay for the brick, then from the site you will be removing some amount of some centimeters of earth, and this process is called as unsoiling, because you don't want the upper surface of the earth or upper surface of the soil, which are mixed with several foreign elements, to get mixed with the ingredients of the brick. That's why you discard this specific few centimeter on the earth. Then from this depth you will be digging out the required clay. Then the third step comes out to be cleaning. Cleaning means removing all the foreign material, let's say vegetative material is there, or let's say some plastic, metal, whatever the undesirable things are there should be get rid of. Then weathering. The mass, the clay mass is exposed to open air and sun. Then blending. All the ingredients are then mixed with the clay mass and they are totally blended to make a uniform dough. Alright. Then tempering. Tempering means applying stress over the dough so that all the uneven amount, or let's say all the uneven distribution of the material takes place properly, so that unified distribution takes place inside the dough. Then the second stage is molding, which is nothing but getting the specific desired shape of the brick. Okay, the process can be hand molding or machine molding. See, the difference between hand molding and machine molding is this is manual process and this is some sort of automatic process. But when we are saying qualitatively which one is better, theoretically machine molding can be said that it is a better, or let's say good process for molding a brick. But when we are talking about hand molding, we are talking about manual inspection of each brick by the expert laborer. That's why skilled laborer. That's why hand molding comes out to be a more qualitative approach towards making of brick. Then drying. Now why drying is important? See, when we said clay was prepared and molding was done, some amount of moisture was there in the dough. Now, if we directly jump from molding to burning, then the problem is that a large amount of moisture will be present in the brick and the burning will be requiring some fuel. The burning will require some sort of fuel, and that's why excess moisture content will be consuming a very large proportion of the fuel in kiln, or let's say clamp. Okay, that's why prior to burning we should make sure that the bricks are sufficiently dry so that they don't consume a large amount of fuel in the clamp or kiln. That's why in open atmosphere you just keep the bricks laid for let's say 3 to 10 days. Okay, almost optimize the period is 1 week. You just keep the bricks, molded brick, in open air, open atmosphere for let's say 1 week, and then you go for the process of burning. Now what burning exactly does? The burning can take place in clamp or kiln. Clamp is let's say a small oven, kiln is let's say a large oven. Depending on how much amount of bricks you are going to put in that oven, clamp can be there or kiln can be there. Now see, whatever the ingredient that we previously saw are homogeneously mixed and the mix is molded and then dried. Now we want all these ingredients to fuse together, to merge together, to melt together and to form a homogeneous object that we call as brick. Okay, that's why burning is important. Okay, burning not only fuses the composition but also strengthen, or let's say brings the brick into its very final or usable format. Okay, so this is the manufacturing process of a brick. Then let's see qualitative classification of brick. Okay, first, second, third and fourth are the 4 qualitative classes of a brick. Now what qualitative class means? See, whenever we say something is first class, then we are looking at utopian quality, means perfect, 100% good. See, the first parameter that we are talking about here in qualitative analysis or qualitative classification, or let's say comparison, is that in first class you will be looking at plain, parallel, sharp edges and perfect dimension, whereas in second class some sort of distortion may be there. Then in third class the edges may be blunt, they may not be totally parallel, the distortion amount will be very high. Then regarding the color, in first, second, the coloration will be fairly uniform, but in third class, overburnt or underburnt bricks can be seen. Overburnt means bluish or blackish coloration will be seen on the surface of the brick, and underburnt means yellow to orange coloration can be seen. Then regarding crushing strength, first class brick has 10.5 Newton per mm square crushing strength. Regarding second class, the strength is 7 Newton per mm square, and in third class the strength is lowest, that is 3.5 Newton per mm square. Then the first class bricks are mostly machine molded, and second third class bricks are hand molded. Then regarding efflorescence, means alkali presence or salt presence in first class brick is nil, that is no, zero. Then in case of second and third class, the efflorescence ranges from little to large. Then water absorption means how much water by its dry weight is absorbed by the brick when it is kept or when it is submerged in pure water. Then in case of first class brick, the amount is 15%. Then in case of second class brick, the amount is 20%. In case of third class brick, the amount goes as high as 25%. Then regarding the on-site test of quality of brick, which is the striking test. Okay, when we take two bricks and strike them together, then the classic ringing sound is obtained, and when this sort of sound is obtained, we say that the brick is first class. Okay, ringing sound may also be obtained when you are trying to do the same with a second class brick, and a damp third sound means a poor sound may be obtained when you are striking together two third class bricks. Then where these bricks are used, what is the application where we have to or where we can use the brick, means first class, second class, third class, all these bricks have their due application in building construction, but they have their specific position. For first class, it is exterior wall, brickwork, short column and arches, where strength and appearance matter. For second class brick, the application is internal wall and compound wall, where strength and in a mediocre way the appearance is required. Then in third class brick, the inner work or the dry situation work is there, we can go for third class brick. Now a special class, that is fourth class, is there, which has no comparison or there are no specific point that we previously were talking about the first, second and third class, but the fourth class is a special one, and in Indian scenario it is called as Jhama brick. Okay, now this Jhama brick do not have the specific brick dimension or shape. They literally look like random stones like this. Okay, but the major advantage of this Jhama brick is that they have very high crushing strength, which range from 15 to let's say 17 Newton per mm square. Means as compared to first, second and third class brick, the Jhama, or what we are saying, the fourth class brick is having maximum crushing strength, but the shape is so distorted, the appearance is so bad that they cannot be used for regular construction. They are used as road ballast. Okay, road ballast means road metal. They are used in foundation or road ballast, and the basic application where strength of the building material is the first or the foremost or the most prerequisite thing. Okay, this is the fourth class, that is Jhama brick. So that was all regarding the constituent and nomenclature regarding the brick, the methodology of making up the brick, and the qualitative classification. We will discuss another topic in another lecture. Till then, take care. Bye bye.